Okay, it sounds like you're having a little bit of trouble with factoring because now that you're in secondary 3, you're seeing factoring of all types of polynomials. So we're going to just go through. I'm going to give you some key pointers to be looking for, and it'll help you know what method to use when trying to decide how to factor, because every type of problem will be different. So the first thing you need to make sure is that all of your polynomials are always in standard form. Now remember, standard form means highest degree to the lowest degree. So looking at this one, it's in standard form because x squared is larger than 2x due to the degree 2 here. This would be degree 1. So just keep that in mind. That's what standard form means. So with something like this, the first thing you need to notice is that we have a quadratic equation from the beginning. Now with quadratic equations, before I even start, I check to see is there something in common right now that I can factor out. So looking at this, I have x squared and plus 2x. Well, both of those terms have an x, so let's factor out an x. Now we have to put what's left inside the parentheses because we were not able to pull out everything. Now, if you don't remember how to do this, go back through and say, okay, I pulled out an x out of each term, so I divided out an x out of each term. Then write what you have left in each case. So right here we have x squared divided by x, and that leaves us with an x in the first term. And then we have plus, and then looking over here at my second term, I have 2x divided by x, and that leaves me with 2. So now we've factored this. We have x times x plus 2. Now we know we're done because these are linear factors, meaning they both have degree 1. So we're done, almost, we're done with factoring, but since these are down to our linear factors, we can now set them each equal to 0 and solve. So we'll take each of those and set them each equal to 0. So we'll set x equal to 0, and we'll set x plus 2 equal to 0. Each of our linear terms, we'll set them each equal to 0 and solve for x in each case. So now x is equal to 0 is done. There's one of our answers. And then we'll subtract 2 from both sides. X is equal to negative 2. And there's our second answer. Now your answers should match up. We had 2 answers, which makes sense because it was degree 2 in the beginning. So you should know right away, I'm going to have 2 answers, 2 solutions, and we do. We got x is equal to 0 and x is equal to 2. So we factored, and then we set the factors equal to 0 and solve. Let's do another one. Looking at this one, the first thing I notice is that it is quadratic, meaning degree 2. Also notice it's in standard form. If it wasn't in standard form, we would put it in standard form. We'd make sure it's set equal to 0, and then we could begin. Well, this is a quadratic equation because it's degree 2. And so we know we can factor quadratics if they're factorable, but if you're being asked to factor, you know it's going to be factorable. So we can go ahead and start factoring. So remember, quadratics have the form ax squared plus bx plus c, where a, b, and c are the numbers in front of the variable. So in this, a is equal to 1 because remember 1 is in front of x squared, and then b is equal to 2 because in front of x is 2, and then c is equal to negative 3. So then we go through and we learn factoring like this. We're doing what multiplies to be a times c, what multiplies to be a times c, and adds up to be b. So a times c would be 1 times negative 3. So what multiplies to be negative 3 and adds up to be b, which is 2, and adds up to be 2. So then we learned that you will list your factors out. So 1 times 3 is 3, and that's the only factors of 3. Now we have to put the negative in the correct spot because it needs to add up to be positive 2. So if we put the negative with 1, let's check and make sure it works in both cases because it has to work in both cases. So negative 1 times 3 is negative 3, and then negative 1 plus 3 is positive 2. So it works in both cases. It must work in both cases for it to work. Now, I'm just going to factor this the long way because we need to know how to long factor. We did learn a trick last year on quick factoring, but remember you can only use quick factoring when your a value in front of x squared is 1. So our original problem, I'm just going to do this the long way so that you guys can know how to factor the long way if you have to. Because remember, if a is not 1, you cannot quick factor. So our original problem was x, let's see, x squared plus 2x minus 3. So I'm going to write that down. X squared plus 2x minus 3, and that's equal to 0. So after we found out the factors, our factors are positive 1 and, negative 1 and positive 3, we do our drop and break. So we drop down our n terms, so we drop down x squared, we drop down negative 3, and then we're breaking down the middle term, drop and break. So we're rewriting that middle term as our 2 factors. Now don't forget that you're rewriting those factors with x's, because this is positive 2x, so we're rewriting those with x's. So now we're going to put those in up here, and it doesn't matter the order, so negative 1x and then plus 3x. So I just put in the 2 factors that I found, and then you group the front 2 terms, and you group the second 2 terms, and then you go ahead and you look at the first group and factor out everything you have in common. So looking at x squared minus 1x, they both have an x in common. I'm going to pull out an x and write what's left inside the parentheses. If you don't know what's left, go back through and divide each term by x to see what's left. So x squared divided by x is x, right there's an x, and then negative 1x divided by x is negative 1. All right, let's look at our next group here, looking at 3x minus 3. They both have a 3 in common, so I'm going to pull out a 3, and then left is, now if you didn't know, go back and divide each term by 3. 3x divided by 3 is just x, and then negative 3 divided by 3 is negative 1. Now remember we learned about our safe haven, those have to be exactly the same or you've done something wrong. Even the sign, that negative, has to be exactly the same or you've done something wrong. So we know we've done this one right, it's our safe haven, because we got the same thing in the parentheses. So our next step will be to pull out our safe haven. We pull out x minus 1. And then, so when we pulled it out, we divided it out. And that left me with x. And then that was positive 3, so plus 3. So now we factored this. Now notice we're done because we're to our linear factors, meaning they both are degree 1. That's x to the first, and that's x to the first. Now when we're down to our linear factors, we can set them each equal to 0 and solve. So we can set x minus 1 equal to 0 and solve for x, and then x plus 3 equal to 0 and solve for x. So we get x is equal to 1, we get x is equal to negative 3. Now notice we have 2 solutions, which makes sense. We better have 2 solutions because in the beginning it was quadratic. Okay, let's look at something a little different. So look with me at this problem. Now the first thing I see here is that this is a cubic equation, and if we're asked to factor it, we've got to think of how we're going to do this. So it's a cubic equation, so it's not quadratic, so we're not going to be able to do what multiplies to be a times c right now. But looking at this one, the first thing I look for when I see cubic is I look at all the terms. 1, 2, I have all terms here, 1, 2, 3 terms. I'm going to look at all of them and see if I have something in common I can pull out. So notice in x cubed, plus 3x squared, and negative 4x, they all have an x in common. So I'm going to factor out an x. Well, we've got to go through and write what's left in the parentheses after we factored out an x. Now let's say you didn't know, go back through and divide each thing by x if you have a hard time seeing what's left inside the parentheses. You pulled out an x, meaning you divided out an x. So go back through and see what's left in each term. X cubed, I'm going to change colors, x cubed divided by x, guys, is x squared. And then 3x squared divided by x is, and it's plus, so it's going to be 3. And then x squared divided by x is just x. So this became 3x. And then right here we have negative 4x divided by x, and so we're left with negative 4. Okay, so that's our first step. Now looking at this, notice we've factored out an x, and now looking at this right here, now we have a quadratic. So you might be done if it doesn't factor any further, but you need to keep going if it does. So we know how to factor quadratics. We just did some examples like that. So once again, now I'm going to ignore this for a minute, not forgetting it's there in the end, because it is there in the end. but I'm going to go through and factor this part, x squared plus 3x minus 4 further. So a is equal to 1, b is equal to 3, and c is equal to negative 4. Ax squared plus bx plus c, because this is a quadratic. And then we'll do what multiplies to be a times c, so what multiplies to be negative 4 and adds up to be 3, adds up to be b. So then 1 times 4 multiplies to be 4, and then also 2 times 2 multiplies to be 4. Let's see which ones would ever add up to be 3. So 1 and 4 could add up to be 3. 2 and 2 will never add up to be 3, so we can eliminate those factors automatically. So we know that it needs to add up to be positive 3, so the negative has got to be with the 1. So our factors are truly negative 1 plus 4, because it works in both cases. So our factors are negative 1 and positive 4, but those are our factors, and I'm only circling them for a second. Those are not my answers, those are my factors that I'm going to use. So then we had the quadratic equation. Remember, our quadratic was this x squared, so x squared plus 3x minus 4. Now notice, remember that you can only use quick factoring if in front of x squared is 1, and it is. So if you remember quick factoring, you know that it quickly factors to be those two things. So it would factor to be x minus 1 and x plus 4, because that was positive 4. But I'm going to do it the long way too, just because you're not going to always be able to quick factor. So remember, I'm going to go through the long way. After we know the factors, we drop and break. So x squared, we drop down our n terms and negative 4. And then we break down our middle term as our two factors we chose. So we chose negative 1 and positive 4, so negative 1x and positive 4x. And then you group the first two terms, and you group the second two terms, and then you go through each group and factor. X squared minus 1x, what do we have in common in x? So then left would be x minus 1. If you need to go back through and divide each thing by x, go ahead and do that. Now moving on to this group, we have a 4 in common, so I'm pulling out positive 4, and that leaves me with x minus 1. Don't make the mistake of saying those 4's cancel out and go away. They become negative 1. Now we're safe. We're safe because we have the same thing in the parentheses, so we'll pull it out, our safe haven. So we divided it out, so it's gone. That leaves me with x and positive 4, so x plus 4. Now once again, we got the same answer that we would have when quick factoring, but I just wanted to do it the long way, just so that we could remember how to do it if we can't quick factor. So x minus 1 times x plus 4. Now don't forget that we had this original x here as well. So our final answer would be x times x minus 4 times x plus 1. So just don't forget about that x that we left alone for a minute, but it is in our final factored answer. So this would be our final answer. And now we can set each of those equal to 0 and solve for x. So we would get x is equal to 0 for this, because we set each of them equal to 0. And we would get x is equal to 4 here if we set that equal to 0 and solve, and we get x is equal to negative 1. So we'd get 3 answers, which, guys, 3 answers makes sense. It was degree 3. We better have 3 answers. Okay, so I'm going to do another one like that I saw on your guys' test here. So looking at this one, 4x cubed minus 12x squared minus 16x, the first thing I notice here is that this is cubed. So then I look through and see, is there something in all 3 terms, the greatest thing in all 3 terms that I can factor out in the very beginning? So notice this one has a 4 and an x cubed, this one has a 12x squared, and this is a 16x. Well, notice that 4, 12, and 16 all divide by 4, so we're definitely going to pull out a 4. But that's not it. This has an, oh, right here. This has an x. Well, this one at least has an x, and this one at least has an x. So we're going to pull out a 4 and an x. We're going to write what's left inside the parentheses here. Now, if you don't know what's left, go back and divide what you pulled out into each term. So I'm going to write that so I have an easy time seeing what's left inside my parentheses. So 4x cubed divided by 4x, those 4's went away. X cubed divided by x is x squared. And then we have negative 12 divided by 4, which is negative 3. and then x squared divided by x is x, and then negative 16 divided by 4 is negative 4, and then x divided by x and is 1. So looking at this right here, now notice we did factor out a 4x, and we've got to keep going. Okay, so now we can ignore this. We factored it out. We'll ignore it for a minute, not forgetting it's in our final answer, but looking at this, it's now quadratic. So it's quadratic because it's degree 2, so we've got to factor our quadratic if possible. So let's use quick factoring, but first of all, we always do what multiplies to be a times c and adds up to be b. So a times c would be 1 times negative 4. So negative 4, what multiplies to be negative 4 and adds up to be negative 3. Once again, ax squared plus bx plus c. So a is 1, b is negative 3, and c is negative 4. Okay, so what multiplies to be negative 4 and adds up to be negative 3? So 1 times 4 multiplies to be 4, and we need it to multiply to be negative 4 and add up to be negative 3. So if you look at this, 1 times negative 4 is negative 4, and then 1 plus negative 4 is equal to negative 3. So it works in both cases. So our factors are positive 1 and negative 4. Now we know that we can quick factor this one because in front of x squared is a 1, so it's going to factor to be x plus 1 times x minus 4. Now don't forget, that was only this piece. That was only this piece. So we can't forget about the original 4x we factored out. So we had 4x, we factored that out in the beginning, and then we just factored this piece, and we got x plus 1 times x minus 4. So we factored. And now we can go through and solve if we need by setting each of those factors equal to 0. Now be careful, we're setting each of them equal to 0. So we'll have 4x is equal to 0. We have x plus 1 is equal to 0. And we have x minus 4 is equal to 0. Solving for x in each case, divide by 4. So we get x is equal to 0 minus 1. So x is equal to negative 1. And add 4. X is equal to 4. Now your answer should make sense. We have 3 of them. We have 3 answers. And it makes sense because it was in the beginning a cubic equation. So we better have 3 answers. So hopefully that helps with that one. Okay, so now I want to show you, a few of you asked me about factoring by grouping. Now, looking at this, first of all, I want to point a few key things out to you. Notice how it is degree 3, okay. So I look at this and say, okay, just like with the others, I always check, do I have something in common I can pull out of everything in the beginning? And we don't because, you know, this 8 doesn't have an R like the other terms. So this isn't going to be like the others that we just did. Okay, but there's one key thing here that I want you to always try to remember. If you have 1, 2, 3, 4 terms, then you're usually going to be factoring by grouping. So it's called grouping. Now this is somewhat similar to what we learned last year, but yet different. Okay, so somewhat similar, same idea, kind of, has some same ideas and same features, but it is different. So factoring by grouping. Now since we have 4 terms, we can try factoring by grouping. I'm going to group the first 2 terms, and I'm going to group my second 2 terms. And now we're going to go through and pull out everything we have in common out of each of those groups. So it is very similar to what we learned last year, but it is a little bit different. So we have 8r cubed minus 64r squared. Let's pull out the greatest thing we have in common. Well, 64 and 8 both have an 8 in common. And then r cubed and r squared, we can pull out an r squared. So let's write what's left inside the parentheses. Now let's say you had a hard time with seeing it. Go back through and divide out what you pulled out. So 8r squared. Okay, so then 8r cubed divided by 8r squared, the 8's divide out, r cubed divided by r squared is r. And then negative 64 divided by 8 is negative 8. And then r squared divided by r squared is gone. It becomes 1. So we factored out that first group. Now let's factor out this second group here. Now this part is the trickiest part. Factoring out the second group, we have r minus 8. So we got to factor out something we have in common. Now you kind of want to say, well, there's nothing in common. But technically there is. Technically, there's a 1 in common. Now, we can always factor out a 1 if we need to. So we're factoring out a 1, and left in the parentheses is r minus 8. Now, once again, we just divide both things by 1. We factored out a 1, and that leaves me with r minus 8. So now you'll check your safe haven. It works the same way. Safe haven. We are safe because we have r minus 8 in both cases. So now it's awesome because we can actually pull it out. Since we were safe and it's in common, we can factor that out. We can factor out our safe haven. So we're factoring out r minus 8, meaning it divides out. And then left inside would be 8r squared. And then this is plus 1, positive 1, so plus 1. So now we have factored this. Now I did notice it just said to factor these, not solve. But if we wanted to solve, we would set each of them equal to 0. So we would say r minus 8 is equal to 0, and then we would set this equal to 0. 8r squared plus 1 is equal to 0. And this one would be easy to solve. We would get r is equal to 8. This one we'd have to go through and use either the quadratic formula because it's still quadratic, or something. But like I said, you were told to just factor, so this would be how you factored. Let's do another one where you are going to factor by grouping. Once again, you know you're going to probably be factoring by grouping if you have 4 terms. So let's do another one. Okay, so I'm going to do this one from, let's see here, from the test. All right, so looking at this one, we're going to do x cubed minus x squared minus 9x plus 6. So once again, the first thing I see is that it's raised to the 3rd degree. Now, there's nothing in all 4 terms we can factor out from the beginning. So now you should know, since there's 4 terms, we're going to probably be factoring by grouping. Because there's 4 terms, we'll probably be factoring by grouping. So we're going to group our first 2 terms, and we're going to group our second 2 terms. Now, make sure you include that negative in your group right there. That is important. So now let's focus on this first group and factor out everything we have in common, the greatest thing we have in common. So in x cubed minus x squared, what we have in common is an x squared. Okay, so we're factoring out x squared, and then left inside, now if you didn't know, you'd go back through and divide each term by x squared. So x cubed divided by x squared is x, and then minus x squared divided by x squared is 1, so don't make the error saying that goes away because it is 1. And now we can focus on this second group here, negative 9x plus 9. Now we learned this last year. If there's a negative in front here, right next to the parentheses, then you'll always factor out a negative with what you're factoring out. So this has a 9 in common, but we're not only going to pull out a 9, we're going to pull out a negative 9 because of that negative in front, right next to the parentheses. That means we're going to factor out a negative. So we're going to go through and divide each thing by negative 9. And write what we have left. So negative 9x divided by negative 9 is just x. And then positive 9 divided by negative 9 is negative 1. Now check your safe haven. Safe haven. We got it correct because it's exactly the same inside the parentheses. You'll know you've done something wrong or forgot to factor out a negative like we did if you don't get this right signs. So go back and check if that ever happens. So now because we're safe, we can pull out our safe haven, so we'll pull out x minus 1. Now when we pull it out, we divided it out, so it's gone. And that leaves me with x squared and minus 9. Now once again, looking at this, we've got to see if it factors further, because sometimes it might. So looking at this piece, it's linear, so we're done factoring that piece for sure. But we've got to check if it's anything greater than linear, if it factors further. So looking at this, it's degree 2. So let's check to see if it factors further. It might, and if it doesn't, then you're done. But we need to check. So looking at this, remember that we're doing, well, first of all, quadratics have the form ax squared plus bx plus c. And in this one, a is equal to 1. Now notice we're missing bx. We're missing bx, so our b is 0. So b is equal to 0. And then our c is equal to negative 9. So we're doing what multiplies to be a times c. and adds up to be b. So a times c will be 1 times negative 9. So it multiplies to be negative 9 and adds up to be 0. So factors of 9 are 1 times 9, 3 times 3. And then which ones could possibly add up to be 0? Those could not add up to be 0, but 3 and negative 3 could add up to be 0. And it works in both cases. Negative 3 times positive 3 is negative 9. And then negative 3 plus 3 is 0. So we know it works in both cases. So our factors are negative 3 and positive 3. Now we can quick factor this one. Look back right up here with me. We can quick factor this one because it was a 1 in front of x squared. So we know we can quick factor it using our factor. So it's going to factor to be x minus 3 times x plus 3. Now don't forget about, this piece just became that, but don't forget about this as well. So what we have now is, so I'm going to write up here so I can stay hopefully on the same page. So we have x minus 1, and we also have x minus 3 times x plus 3. So we're done factoring it. Now if it said solve, we will look at our linear factors and set them each equal to 0 and solve for x. So we have x minus 1 is equal to 0. We have x minus 3 is equal to 0. And we have x plus 3 is equal to 0. Now solve for x in each case. So we'll get x is equal to positive 1. We get x is equal to positive 3. And we get x is equal to negative 3. We have 3 solutions to this equation, and it will make sense. It will make sense because in the beginning it was a cubic equation, so we better have 3 answers. So this one was a little bit lengthy. We had to do a couple steps, quite a few steps to be able to get to where we wanted, but we were able to do it. So once again, factor by grouping, pull out your safe haven, and then you'll probably have to factor that quadratic down even further. Okay, I want to point something out though. On number 12, I noticed you tried to factor by grouping, but you can't factor by grouping in this one. It was a smart choice to try because you saw you have 4 terms. So you said, I'm going to see if I can factor by grouping. So we grouped the first 2 terms, the second 2 terms. I did see you made some errors though. Let's look through it real quick. So we have an x squared in common. So then left would be x. In this first group, we have an x squared. So then left would be x plus 2. And then in this group, we have a negative 2 in common. So we'll pull out a negative 2. So then that leaves me with 3x plus 2. Now look at this. Can we factor by grouping in this one? No, because our safe haven isn't the same, and we've done this all correctly. So now notice there's nothing we can do at this point. We cannot keep going. We've got to stop. We can't factor by grouping in this one because our safe haven didn't come out to be the same. So you have to have a different method to decide if that x minus 2 is a factor, and we'll talk about that later. I want to keep going with factoring for now, but that's just a good example of when you know, okay, factoring by grouping didn't work in this problem. So just because it has 4 terms doesn't necessarily mean it will factor by grouping, but you'll always try that first because a lot of times, especially if they say factor, they'll want you to, they'll make it factorable, but it won't always factor. But there are different methods to be able to figure that out. Okay, anyways, here we go. And you know what? I decided to finish this one off while we're on it. So is x minus 2 a factor? So I like that you tried to see you tried to factor it by grouping, but grouping didn't work, so you couldn't factor it and look. So we'll have to do this a different way. But if you think about this, a factor is, so this is a linear factor. So we know if it is a linear factor, then x minus 2 can be set equal to 0. And then we would solve for x by adding 2 to both sides. So x is equal to 2, okay? So now if x is equal to 2, then this would be a factor. Now we could check this. Now this is how. Now this must be equal to 0. This whole polynomial is equal to 0. Now if x minus true is truly a factor, then when we plug in what the actual root is, so we solve for the root, we solve for the answer. Now if we go and plug that back into our equation up here, it better be equal to 0 after we plug that in. So let's plug it in and see if we get 0. So we'll put in 2 cubed plus 2 times 2 squared minus 6 times 2 minus 4. When we plug that in, that root, it better be equal to 0 or this is not a factor. So 8, 2 cubes 8, and then plus 2 times 4, I'm just going to show all my work, and then minus 12, 6 times 2 is negative 6 times 2 is negative 12 minus 4. So we have 8 plus 8, 2 times 4 is 8, minus 12 minus 4. So we have 8 plus 8 is 16. Here we go. 8 plus 8 is 16, and then minus 12 minus 4. Well, if you sum that up, you get 0. So what we have here, guys, is a true statement. We have 0 is equal to 0 when this is a root. Thus, this must be a factor. So if we got any not true statement, let's say we plugged in 2, the actual root that we got given this factor, let's say we plugged it in and we got something like 9 is equal to 0. Well, that's not a true statement, so we would say this is not a factor. So this wouldn't be a factor. But since 0 was equal to 0, it truly was a factor. So the important thing is, though, is that you solve for x using that factor first, just like we did right here, before you go and plug it in. Then go and plug it in, and then make sure it is equal to 0 once you plugged it in. That's how you can check it. Okay, so now I'm going to teach you how to factor the sum or difference of two perfect cubes, okay? So now I saw you sent me this picture with something that looks like this. Well, you know it factors to be this form. I'm going to teach you a little quick thing to help you think through that, hopefully, and not have to memorize that, because that's a little bit hard. Okay, so what you're going to do is think through this with me here. If we take the cube root, so what makes it a perfect cube is that if you take a cube root, then it's going to come out to be a whole number with no decimals. So if we take the cube root of a cubed, then notice our root cancels out with our power and gives us a. So that's where our front term comes from. And then if we take the cube root of the back thing here, so the cube root of b cubed, then our root cancels out with our power and leaves us with b, and that's where the back comes from. So this is just a little tricky like saying type song to help you remember this. So this, it works like this. So first of all, the song doesn't start till after you do this first step. So I'm going to show you how to write this out without having it memorized. So that's what I'm doing right now. So the first thing I'm going to do is figure out my front and back by taking the cube root of the front term and the back term. And then I'm going to do my parentheses, and I'm going to put in the front term, which is a, and the back term. Now, you always look at what sign you were given in the beginning. So look back up here with me. It was a negative in the beginning, so you put in a negative here. And then your song begins. So you'll put your parentheses and your song begins. So you'll do, the song goes like this. The front with the front, then the front with the back, then the back with the back. So I'm going to start again. The front with the front. So the front with the front is a times a, which is a squared. Then you'll do the front with the back. So the front with the back. So that would be a times b, which is ab. And we won't fill in the signs till later. And then we'll do the back with the back. So b times b is b squared. Now we'll go through and fill in our signs. So we'll close our parentheses and go through and fill in our signs. Well, this is how the signs work. You already filled in the minus sign because you knew in the original problem it was minus. Well, the sign that comes next will always be opposite of that. So if this is minus, this will be positive. And then our nth term here will always be positive. Okay? So I'm going to do it again with the sum. This was the difference of two perfect cubes. Difference meaning subtraction. I'm going to do this little song to help you not have to memorize it, but just a little bit of a way to help you actually memorize it. One more time. Okay, so once again, I'm going to show you how to do this without having to have this memorized. It's the same thing, it's just writing it out. It's just thinking of it using that little trick I taught you. So to find the front term, you'll take the cube root of the front thing here. So the cube root of a cubed, our root cancels out our power. Our front thing is a, our front is a, and then our back thing is the cube root of the back term, the cube root of b cubed, our root cancels out with our power, so our back term is b. So now you'll go through your little process thing. You put your parentheses. Our song doesn't start yet. Just a second. I'm trying to get my colors to work here. Okay, let's get them working. Had a bit of a malfunction. Now I got it fixed. Okay, so now you'll go ahead and do your process here to factor it with our little trick. So you put in your front term and your back term. Then your sign on the very first thing will always be the same as the sign you started with. So then your song begins and you can fill in the rest. It's the front with the front. So that's a squared. Then the front with the back. So a times b. Then the back with the back. So that's b squared. And then you go through and fill in your signs. Well, this is plus because we started with plus up here. Well, this sign is always the opposite. The one directly after is always the opposite. And then this sign on the end is always plus. Okay, so now that you know how to factor the sum or difference of two perfect cubes, let's do our first example of factoring something like that. So if we were asked to factor something like this, the first thing I noticed is it's degree 3, and there's just 2 terms here, 1, 2 terms. So now I'm going to try to use the sum or difference of two perfect cubes, that little factoring trick. So they're not going to usually say these are two perfect cubes, factor by that little trick. You're going to have to know I have 2 terms and they're both perfect cubes. So to know that they're both perfect cubes, you'll take the cube root of the front thing. So the cube root of x cubed is x. So that's going to be our front thing we're going to use. And then you'll take the cube root of the back term, not including the sign. This is a difference of 2 perfect cubes because the subtraction means difference. So do not carry the sign through when you start doing this next part. Okay, so now we'll take the cube root of 8, which is 2. You could do that on your calculator. So our back thing is 2. So just take the cube root of the front term and the cube root of the second term. So now you can factor this using that cute little thing I just taught you. You throw in parentheses and then you put your front term in and your back term in. And then your sign is always what you started with. So it was minus, so this will be minus. And then your song begins. You do the front with the front. So x times x, which is x squared. Then you do the, I'll change colors, then you do the front with the back. So that would be x times 2, which is 2x. And then you do the back with the back. So the back with the back, which is 2 times 2, which is 4. So we go through now and we decide what our signs are going to be. Well, if this was minus, then this is always the opposite. So this will be plus. And so this on the end is always plus. Remember, the end one's always plus. So now we've factored this down so far so good. But we need to check and see if this over here on the left factors any further. Now remember, this is our linear factor, so we're done with that one. But looking here, we have a quadratic, so we would say, okay, we know how to factor quadratics. We'd say what multiplies to be a times c and adds up to be b. A times c is 4 and 2, b is 2. So what multiplies to be 4 and adds up to be 2? So 1 times 3, 1 times 3 does not equal 4. Okay, let's see here. 1 times 4 is 4, and 2 times 2 is 4. Now, neither of those can add up to be 2, so we are actually done here. This doesn't factor any further, so this is our final answer. So we're done. Now, once again, though, if we were asked to solve, we could go through and solve, because we'd set each of these equal to 0 and solve for x, and we know how to solve this by using the quadratic formula. But I think on your test it said just to factor it, so this is where you'd stop. Let's do one more like that. So we were asked to factor x cubed. Let's do plus 64. Now, once again, the reason I know I can solve using this cute little thing I taught you, factor using this cute little thing, is because we have 2 terms, and this is the sum of 2 perfect cubes, meaning x cubed is a perfect cube and 64 is a perfect cube. So to find your front thing, take the cube root of the front thing, so the cube root of x cubed, and you get x. And then take the cube root of 64, and you get 4. So our front thing is x, and our back thing is 4. So then you do your little song. Well, first of all, you put your parentheses and you put in your front term, which was x, and then your back thing, which is 4. Then you look at the sign that you started with. It was plus, so this must be plus. Then you keep filling it in. So we're going to fill in the rest of our parentheses, and this is where our song begins. And you do the front with the front, which is x times x, which is x squared. Then you do the front with the back. So then that's 4 times x, and then you do the back with the back. 4 times 4 is 16. Then you fill in your signs. This is plus. This is always going to be the opposite sign, so this will be negative. And then this one in front here is always going to be plus. So then once again, we could check to see, okay, well, looking at this front thing, this x plus 4 here, it is linear, so we're done factoring that, but we would need to check to see if we could factor that further. So what multiplies to be 16 and adds up to be negative 4. So 1 times 16, 2 times 8, 4 times 4. None of them can add up to be negative 4 no matter what. So it doesn't factor any further. So this would be our final answer if we were just asked to factor. Now, once again, keep in mind, we could solve for it, though, if we wanted to solve, because they might ask you in the future to solve. Set each of them equal to 0, so you'd set x plus 4 equal to 0. You'd set this equal to 0, but then you'd have to solve by the quadratic formula, because it's not factorable. But if they ask you to factor, we're done with as this, okay? All right. Okay, this next part, I'm going to change gears now that we know how to factor. Really, you'll use all of those things to factor things. But really at this point now, I think you should be able to factor about anything they hand you. Just go through those key points. Does it have 4 terms? If it does, try factor by grouping. Does it have 3 terms? If it does, is it quadratic? Is it cubic? What do we have? So can we factor out something in the beginning? And then do we need to keep going? There's just, I showed you many different ways to go through and factor things. So just keep those little key points in mind, and you should be able to tackle pretty much any problem with factoring. Now, I noticed on here it says, find the zeros and write a polynomial in standard form. So I'm going to show you how to do that real quick. So if you were given something like this, and you were asked to if you were asked to find the zeros, and then write the polynomial. First of all, finding the zeros is really easy because notice this is already in its linear factors. So this is already in linear factors. And, you know, the whole point of factoring is so that we can set linear factors equal to 0 and solve. So this one's already factored. So the finding the zeros part's really easy. Set each of those equal to 0. So x is equal to 0, x minus 3 is equal to 0, and x plus 2 equal to 0, and solve for x in each case. So we get x is equal to 0. There's one of our solutions. We get x is equal to 3. There's another solution. And then x is equal to negative 2. So we have our 3 solutions. Now, if we want to find the polynomial that this is, we've got to, yes, go through and multiply this all out. Now, take my suggestion and multiply 2 together first before you start multiplying all of them together. It gets really confusing if you try to multiply all 3 at once. So let's just focus on this portion and multiply it out. So now we've got to double distribute. So we have x times x, which is x squared, and then x times 2, which is positive 2x. And we're double distributing here, so negative 3 times x is negative 3x. And then negative 3 times positive 2 is negative 6. Now, before you multiply the x in, combine all like terms here. So we have x squared, and then 2x minus 3x is negative 1x, or negative x, same thing. So we have minus 6. Now, don't forget we're multiplying x through to all that stuff, but this way, if you focus and multiply these 2 things together first, it makes it easier. So x times x squared is x cubed, x times negative x is negative x squared, and x times negative 6 is negative 6x. And this would be your polynomial of least degree that had those zeros. And so we solved for the zeros. We had x is equal to 0, x is equal to 3, and x is equal to negative 2. Okay, so now if we were going to work backwards, if we were given x is equal to 2, x is equal to negative 3, and x is equal to 5. and we were asked to find the polynomial. We've got to work backwards. Well, we know if these are the roots, then to get these roots, we had to have linear factors. So we're going to work backwards on this. So I'm going to get this equal to 0. So I'm going to subtract 2 from both sides. So we have x minus 2 is equal to 0 now. And then we're going to add 3 to both sides, add 3. So we have x plus 3 is equal to 0. And then we minus 5, minus 5. So x minus 5 is equal to 0. So I'm working backwards in this one to find the polynomial of least degree with these roots, given these roots. So this is a different problem. Okay, so now that we're here, notice they're all equal to 0. So we're working backwards here. We can put them back together and say x minus 2 times x plus 3 times x minus 5 is equal to 0. So we're working backwards. We're going to bring these back together, and now we'll multiply them together. Now, I would focus on 2 of them and multiply those together before I try to multiply all 3 of them together. So I'm going to ignore this for a minute. X times x is x squared. X times 3 is positive 3x. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. Once again, combining like terms before I do anything. X squared and then plus x, because 3x minus 2x is positive 1x minus 6. So I just combined all like terms, and now I won't forget that I have to multiply that through to my x minus 5. But if you multiply 2 together first, you're going to make less errors. So now we've got to double distribute. Now I'm actually going to rewrite this as x minus 5 times x squared plus x minus 6, because I like to have this in front. It makes it easier for me to multiply it and not make any errors. So now we're going to double distribute, focusing on x. X times x squared is x cubed. X times x is x squared, and it's positive x squared. X times negative 6 is negative 6x. And I've got to double distribute, so negative 5 times x squared is negative 5x squared. Negative 5 times x is negative 5x. And then negative 5 times negative 6 is positive 30. And then combine all like terms, starting with my highest degree and working my way down. X cubed, no other x cubes. I have 1x squared minus 5x squared, which leaves me with, negative, I gotta start here. So we have x cubed, and then we're adding 1x squared minus 5x squared, and that leaves me with negative 4x squared. So I just took care of those. I cross them out as I go so I don't make any errors. Negative 6x minus 5x's is negative 11x's. Just combine those, and then plus 30. So this is the polynomial that had those zeros. So this time we were working backwards. Okay. In something like this, if we were asked to list the roots and then figure out the polynomial, we've got to be careful with this one. Because what we have here is we have x minus 1 times x minus 1, because that's x minus 1 squared, and then times x plus 2. So now, first of all, let's find the zeros. So we know that we can set each of those equal to 0. So x minus 1 is equal to 0, x minus 1 is equal to 0, x plus 2 is equal to 0, and solve for x in each case. So we get x is equal to 1, x is equal to 1, and x is equal to negative 2. Now notice something about this. We get x is equal to 1 twice. So they'll actually write out the answer in this one as such. So you'll actually write out the answer like this. If I can get my thing to scroll down. Just a second. Sorry about that. My smart board keeps having like major issues and I can't figure out what the deal is. So we'll actually have here, we'll write it like this. We'll write it such as x is equal to 1 with a multiplicity of 2. So what I mean by with a multiplicity of 2, let me get that down. With a multiplicity of 2. What a multiplicity of 2 just means is it happened twice. So we get x is equal to 1 with a multiplicity of 2, meaning it happens twice. And then we get x is equal to 2 on negative 2. So once again, we had 3 solutions, but this is how they would want you to write it. X is equal to 1 with a multiplicity of 2. Now, if it happens 3 times, you'd say with a multiplicity of 3. And then x is equal to negative 2. Now, if we wanted to find the polynomial, we'd have to go through and actually multiply it out. Now, I would suggest starting here and focusing on two of them first and multiplying those together. So x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. Before you multiply this through, way before, you should combine like terms to prevent any errors. So we get x squared minus 2x's. Those add up to be negative 2x's, and then plus 1. Now that we have this, now we can multiply x plus 2 through. But I would suggest focusing on 2 at a time like I just did. Otherwise, it gets messy in some places. So let's go through and multiply this out really quick, and then I'll see if there's anything else we need to touch on, and then I think you're good. X squared times x is x cubed. X squared times 2 is plus 2x squared. Now notice I'm doing this one a little bit different. I should have wrote this in front, but it's okay. I'll just keep going with it. As long as I distribute through every term, I'm okay. Negative 2 times x is negative 2x squared, and then negative 2x times 2 is negative 4x. I'm doing it even color coding it. And then 1 times x is 1x, so plus x. And then 1 times 2 is plus 2. And then combine all like terms. My largest degree is x cubed, no other x cubes. Then I have 2x squared minus 2x squared. Those happen to cancel out. And then we have negative 4x plus x, which is negative 3x's, and then plus 2. So this would be our polynomial, and we're done. Now, it might give it to you like this. If x is equal to negative 1, 0, and 2 in problem 10, this is what it looks like. Split it up. We know that that means x is equal to negative 1, x is equal to 0, and x is equal to 2. And then we're going to work backwards to get our polynomial. So I'm going to add 1, x plus 1 is equal to 0. Now with x is equal to 0, we're good. And then minus 2. So we have x minus 2 is equal to 0. Now notice since they're all equal to 0, we can bring them back together and multiply them now. So we have x plus 1 times x minus 2, and then don't forget about that x. Yes, that x is there, and you asked that on the paper, and yes, that is where that came from. So then we'll go ahead. It depends on your teacher if they want you to actually keep multiplying that out. But if they do, if you can stop there, you could be done. But if you do need to multiply it out, multiply those two together first, combine all like terms just like we did in the other two problems, and then distribute the x through. Okay, number 13, it says find the zero. So looking at this, we have 3 terms. So we're going to go ahead and see how should we factor this since we need to find the zeros. If it factors, and looking at this, we do have something in common in all 3 terms. We have a 2 and an x in common. So let's factor that out. And once we factor that out, we can go back through and figure out what's left by dividing each thing by 2x. So then that leaves me with 4 divided by 2 is 2, and then x cubed divided by x is x squared. And then we have negative 2x squared divided by 2x. And so we get negative 2 divided by 2 is 1, so negative 1. And then we have x squared divided by x, which is just x. And then we have negative 2x divided by 2x, which is negative 1. Now, once again, we would now go through and continue to factor this. And so we're doing what multiplies to be a times c. What multiplies to be a times c, and a is equal to 2, b is equal to negative 1, and c is equal to negative 1. What multiplies to be negative 2 and adds up to be negative 1. Well, 1 times 2 is equal to 2, and that's it. It has to add up to be negative 1, so that needs to be with the 2. So 1 and negative 2 are our factors. Now notice because in front of a it's not 1, we're going to have to long factor. So let's just keep it. I'm going to write this over here. Our factors are our factors are positive 1 and negative 2. And then I'm going to go through and factor this. Now we've got a long factor, but I think we're okay with long factoring. It takes us a long time, but we can do it. So I'll quickly factor this. So we're going to drop and break. So you're dropping down your end terms. Now don't forget about this, but we're going to ignore it for now. So we're dropping down the end terms, 2x squared, and then negative 1, and then we're breaking down the middle term. So we're rewriting down our middle term as our two factors, but with x's. So it'll be positive 1x and then minus 2x. And then now we're going to throw parentheses around our first two terms and our second two terms. And then in this group, we're going to factor out everything we have in common. All we have in common is an x. And then if we go back through and divide each thing by x, we can see what's left. 2x squared divided by x is 2x. And then positive 1 divided by x is positive 1. And then looking at this, now notice we have a negative in the front next to the parentheses. So we're going to pull out a negative with whatever we pull out. And it looks like the only thing in common here is a 1. So let's pull out negative 1. And if we divide each thing by negative 1, then negative 2x divided by negative 1 is 2x. Negative 1 divided by negative 1 is plus 1. And check your safe haven to make sure you've done this correctly, and it looks like we have, because look, in our parentheses is exactly the same. So you pull out your safe haven, x plus 1, so it divides out, and that leaves you with x minus 1. Now don't forget about that original 2x we had in the beginning problem, so just don't forget about it. We also had that, so we had that 2 and x. And now that we factored it, we can set our factors each equal to 0 and solve. So 2x is equal to 0, 2x plus 1 is equal to 0, and x minus 1 is equal to 0. And then solve for x in each case. And so we get divide by 2. So x is equal to 0. 0 divided by 2 is 0, minus 1. So 2x is equal to negative 1, divided by 2. So x is equal to negative 1/2. There's our second answer. And then add 1, x is equal to 1. We have our three solutions, and it took us a while to get there because we had to factor it. And then we had to use so we factored it, and then we had to factor our quadratic, and it was long factoring. So that one was actually quite a long process, but hopefully you understand it now. Okay, just the last few for you. I'm going to go ahead and do 21 on I think it's the review call, probably. So I'm going to go through and look at this one. Now, once again, looking at this, before we can get started, we need to put it in standard form and make sure it's set equal to 0. So I'm going to subtract 27x from both sides. So then over here on the left, I have 3x cubed plus 3x squared minus 27x, and it's now equal to 0. Now, once again, we have three terms, and so I'm going to look and see, can I factor something out right in the beginning? Because we're not starting with a quadratic. If it was, we could just go. But looking at this, we have something in common. We have a 3 and an x in common, so I'm going to factor that out. Now, I'm going to go back through and write 3x divided by each term so I can see what's going to be left inside the parentheses. So then 3x cubed divided by 3x, the 3's are gone, x cubed divided by x is x squared. 3 and 3 divide out here, x squared divided by x is just x. So then it was plus, and then negative 27 divided by 3 is negative 9. X divided by x is 1. So now here, guys, notice we're down to our linear factor there, but this is a quadratic, so we need to keep factoring if possible. So what multiplies to be negative 9 and adds up to be 1? What multiplies to be a times c would be negative 9, and adds up to be b is 1. So the only factors of 9 is 1 times 9 and 3 times 3. Neither of those could add up to be positive 1. And so this does not factor. Okay, this does not factor. Let's see, does it say find the roots, real or imaginary? Okay, so this is 21. Yeah. Okay, so now remember we can't solve a quadratic by factoring if it's not factorable, but we can still solve the quadratic. So just don't forget that. Right here we'll set 3x equal to 0. We'll set x squared plus x minus 9 equal to 0. Now here it's easy to solve for x here. We'll divide both sides by 3. We get x is equal to 0. But this part's going to take a little bit longer. We'll have to do our quadratic formula. So a is equal to 1, b is equal to 1, and c is equal to negative 9. So then quadratic formula here, x equals negative b plus or minus the square root of b squared minus 4 times a times c, and then all over 2 times a. So let's plug it in. So we get x equals the opposite of b, so -1 plus and minus the square root of b squared, so we'll do 1 squared minus 4 times a is 1, times c is -9, and then that's all over 2 times a is 1, so continuing. So we get x is equal to -1 plus or minus the square root of 1 squared is 1, and then in your calculator you have to type it in as -4 times 1 times -9, and if you do that, it's going to come out to be positive 36. So that whole thing becomes positive 36, so you'll have plus 36, and then that's all over 2. 2 times 1 is 2. So then we have x is equal to -1 plus and minus the square root of 37 all over 2. So then this is where you go off to the side and see if this root can simplify any further. So you'll take the square root and you know how to break it down. So 1 times 37, those are the only factors of 37. Nothing else divides by 37. So we have to leave them under the house. There's only one of them. So it's going to stay as the square root of 37. So we have the answers. X is equal to -1 plus and minus the square root of 37 all over 2. Those are two answers right there. -1 plus the square root of 37 over 2 and -1 minus the square root of 37 over 2. There's two answers, but we know it was cubic in the beginning and we should have 3 answers. And we actually did. Remember that we also had x is equal to 0. So we have those 2 answers and x is equal to 0. So notice these are real solutions. Those aren't pretty solutions. They're not rational, meaning we can't write them, we have to write them like this. They can't be written as a fraction. If you type that into your calculator, you'll get a decimal that can't be written as a fraction. But I'm sure your teacher wants this pretty answer because we would expect that of our students in secondary 3. So that's how you would do that. So if you get to a quadratic and you can't solve it by factoring, just use the quadratic formula. Okay, so I'm going to do number 7 on the test. It says, what's the polynomial with the zeros -4, -5, and 4? So zeros are x values, so we have x is equal to -4, x is equal to -5, and x is equal to +4. Now, if we want to know the polynomial, guys, remember we're going to be working backwards, so we've got to get this set equal to 0, these linear factors. So we're going to have x plus 4 is equal to 0, and we're going to add 5, so we'll have x plus 5 is equal to 0. And we're going to subtract 4 from both sides. So we have x minus 4 is equal to 0. So that'll be 0, 0, 0. Now we're working backwards, so we're going to go ahead, and since they're all equal to 0, we can bring them together and say that x plus 4 times x plus 5 times x minus 4 is equal to 0. And then you can find a polynomial by continuing to multiply them out. Now my suggestion is to start with these two and distribute them through. And find that and simplify that first. So we'll get x squared plus 5x, and then positive 4x. And then 4 times 5 is positive 20. Before you multiply this in, combine like terms. So we have x squared plus 9x plus 20. And then now multiply in that other thing, that x, now multiply in x minus 4 into those things. And we've got to distribute. I like to write this x minus 4 in front. So we have that, and then x squared plus 9x plus 20. So then from there, you'll go ahead and distribute x through to each term, and then you'll distribute this -4 through to each term, and then you'll combine like terms. You're going to have some things cancel out here, and that's going to be okay. I'm not going to finish this one just because this video is getting long for you poor, unfortunate souls watching. Okay, I think I'm going to end my video here just because it's getting long. If you guys need help with anything else in particular ever in the future, please ask. Thank you. I'm so glad to help. Hopefully this was